So today we're going to talk about one of the most important questions relevant to the entire Jaseci ecosystem, and that is why. So I spent a lot of time talking about software architecture, the what it is, etc. But the burning question is why? Why learn something new? Why take on a new extension of Python? What do I get if I do this? And what's the thought process behind it? So we're going to talk about that today. And the way I think about it really is from the perspective of, let me just make sure you can see this, from the perspective of whenever anything new is being introduced, you have this kind of curve of everyone, right? Everyone, you're going to have some skeptics, you're going to have conservatives, folks that are going to wait until something's big and already established to really engage. We've already got the enthusiasts and the visionaries. They're there, they know, but I'm really talking to the pragmatists on this in this video. I want to talk to the folks who want to make a good decision as to, is this worth investment to change and improve and adapt the tools that I have in my satchel for building software. So we're going to talk about the why and some of the thought process behind these things. And I think a good way to start is by looking at really the story arc of the main website, right? So this is the Jaseci website. And, we start with this, a statement, enabling fast, low complexity development of AI-powered scalable applications, right? There's a lot of information in here, but it really encompasses pretty much a lot of what the main mission is. We recognize that applications has fundamentally changed, and I've got remember this picture, right? Of applications has fundamentally changed since the 80s, right? Most of these abstractions that we use today were conceived in the 80s, and we've been using it ever since. But now our applications are scalable. Now most of the software that we're building is going to have millions of users and live in a distributed cloud environment while talking to a client side, whether it's a phone or a website, etc. Like that's what programs look like. They're scattered. And also now programs are going to fundamentally start looking different because we're co-designing code, conventional code that we know, and we're also talking to LLMs in that code, right? We're doing prompt engineering for all the hot new startups and products out there. Apple, Google, Microsoft, all these companies are spending heavily on the development of these agentic AI systems and these auto coding systems, etc. So our programs are starting to look like this, right? This is a program in the modern world. You know what I mean? And so how do we, could we do better, right? Now, in order to even think about doing better, you're going to have to crack the mold, and you have to do it intelligently. So we do crack the mold, right? We crack the existing languages mold and realize that we need the flexibility to improve things by adding new features to the way we build software. So I'm going to talk about those features today. I'm going to convey exactly what is in here that we believe, and we found in the cases we've seen so far, we found it to be incredibly helpful. And we believe it'll be incredibly helpful to everyone, in their pursuit of writing awesome modern software. So, okay, let's just go through. Now, the first thing we emphasize on this site is that Jack supersets Python. And this is a very special kind of superset. Indeed, I'm not aware of any real projects that superset quite like this for Python. So, there's languages like Mojo, there's languages like Codon, beautiful projects. I love them because I'm a nerd. However, they may say they superset, they don't say it as much anymore, but that's different. That's talking to Python. Here we fundamentally superset Python. We extend the Python ecosystem with new abstractions. And that new abstractions come with a couple features. So we have this language compiler. That language compiler can compile traditional Python, and it can compile Jack, which is a language designed for us to superset Python's capabilities and abstractions and idioms with additional capabilities, abstractions, and idioms. And you can do that very simply, right? So this picture really conveys how we take our approach. And here you can simply import Jack modules alongside in your Python. So import a Jack module in your Python, and then every Jack module can talk to any Python import. The import syntax is a little bit different. We think this is more readable. It's inspired by other languages, but it's the semantics are equal to Python semantics, even though the syntax might look a little different. But you can import any Python module that's in your Python environment into any Jack module, and then you can import any Jack module into your Python modules, right? And so with this kind of mentality, we allow, and this is really just we haven't talked about features yet, right? We're really just talking about some of the tenets and the attributes of this ecosystem, but it's to support development models like these two, right? So these are the two kind of development models that we support. Now, everything ends up being Python bytecode. So when you run a Python script, all of your Python turns into bytecode, and your Python VM, Python 3, that program will run bytecode. That's what's executing on your computer. So you can write your Python files in a project. You have multiple Python files. You can throw in some Jack files next to it if you wanted to use some of the Jack features. And then when you run, you're actually just, Python can't tell. Python doesn't know that it's running Jack, right? So this is one model, add Jack to your Python project. The other model is to add Python to your Jack project. So if you have a legacy module, or if you want to go Jack first and like really build everything in Jack, because at the end of the day, you have all the semantics plus. You can also create a project where you add Python to your Jack project. This is the way we suggest doing it. What I'm going to show you later at the end of the video is how you can not have to deal with any kind of mixture of code and use Jack as a library. Being that everything is Python bytecode, it also gives us the ability to easily have all of the abstractions expressed as decorators. Now, in some cases, this would be a weird thing to do. Actually, if you look at a lot of these decorator libraries, they're kind of weird it's not elegant. And so we don't really recommend that approach, but we support it fully. And it's almost a happenstance attribute of this methodology of supersetting. And I'll show you later, it's going to be very juicy, it's like bonus, how you can take any Jack module and generate pure Python automatically, and then you can just use all Py files and have the Jack abstraction. I'll show you that at the end. But these are the two models for mixing and matching. And of course, you can go all Jack if you wanted, right? So these are the tenets, just to make sure we support developers where they are. We want to give them the abstractions, but also not make it hard. And we want to extend the Python ecosystem with these abstractions. Okay, good. So that's a tenet. So we tell that story at that point in the site, right? So that's what we're trying to convey there. Now here, this is the important place, and I'll probably not go further because then it's all more stuff that you can read, whatever. But this is the important part that you might want to hear me explain. And this is the 3 categories of features that extend Python semantics in ways that can assist in how we build software, allowing us to be more powerful super developers, right, of large-scale software. So I'm going to talk about the first one. There's 3 here. The first one is programming abstractions for AI. Right here, we're going to talk about essentially the bi-LLM stuff. Now, just as a side note, everything is built where you can build your own plugins to replace how these abstractions work. I'm just going to say that as a side note for the nerds who might want to get under the hood and then change some of the implementations of like how these abstractions work. But let's talk about this abstraction. So this is a traditional program on the right? So if you want to build, say, an AI thing in Python with a traditional approach, you have to do like a lot of boilerplate, right? You'll have to express like what your tools are and so forth, or like how to integrate into the code. You'll have to put a system prompt in to tell the AI what to do. This is very standard how you build prompt engineered software that does something agentic, that uses prompt engineering. And then you've got your client here where you create the interaction, the message, and so forth to the model. This is very standard, and then you do your thing, right? So that's this approach. Now, the problem with this approach is this is incredibly difficult to deal with at scale for developers. Indeed, prompt engineering as an art isn't really well understood how to do it well, as you know, right? Now, one of the key abstractions that we bring in to the fold is this by keyword. And what this by keyword does is it's a new piece of science. We have a research paper that describes it in depth. published at one of the top tier places you can publish new innovations in computer science. It's called OOPS and actually the event is happening at the time of this recording in 1 month from now. So you're getting an inside scoop if you watch it like at launch of this video. But this describes why it works, and it actually works better than prompt engineering, which has been a surprise to us. It turns out that if you don't do something like this and you do the most simple by keyword, so that turns into this, it actually works better than prompt engineering. Now, here's why. It's thinking about prompt engineering as an automated system that your language compiler and runtime should do for you. It turns out that in many programs, you can read the program, and if your brain can understand what the program is supposed to do, like in this case, the hypothesis of this work is a compiler can take that information that your brain can understand what to do and encode it into the runtime. So you don't do the prompt engineering, you let the compiler runtime help you. And you can still control the behavior of the LLM, and that comes through another keyword that we'll introduce whenever, in future videos. It's called the sem keyword, where you can control that AI goodness, but you're not doing the prompt engineering. It's using tons of information beyond what you can even have when you're writing a prompt to actually control the LLM. Anyway, so that's under the hood. You can read the paper if you want to know the science, but as a developer, you basically build your programs like this, right? Where, the syntax looks familiar. It's an import. You have an LLM object in, a global LLM object. This is a class. This object memory details is actually the semantics of a data class in Python. If you look at Python and you understand how data classes was introduced after Python was created in 2017 or 2018, it's actually a standard part of Python. You can have data classes, right? It looks like this, right? Data classes in Python. So it looks like this. Oh, well, here we have a nice AI thing. You can do a data class in Python out of the box. Now, if you look at this PEP, the Python enhancement and proposal, it'll become really clear that somebody was trying to fix how classes work in Python. You know what I mean? I'm not going to get into too much detail in this video on that particular point, but we just create that option. You still have class in Jack, but you also can have a more elegant data class semantic view of classes, which is more standard from an object-oriented standpoint. You have that option. So we use that in this particular example. But just to get, okay, so this is just a class, long story. We have a sem keyword here, right? And then by LLM, and everything just goes, right? And we found, and that's what this blog kind of touches on it, we found this is a production use case, right? This is a sophisticated use case, and it's a prompt that looks like what people actually write for these coding agents and so forth. All of this code turns into this code with the by keyword. Now, I'm just describing this as to the benefit to the developer. And I would love to get into the technical, but that's going to take too much time. But one thing I'd highlight here is we have this type, list of plans, and this by keyword with this information, the LLM knows exactly what to do for this sophisticated agentic coding agent use case instead of doing all of this code. Now, the thing that's really interesting is it actually works better, right? And you'll have to read the paper. You'll have to dig a little bit deeper to understand it. You should tinker with it, get the touch and feel of it, and then you'll understand why it's do better. So that's one value add, okay? That's one abstraction that you get when you, with this ecosystem of tools. Now the other one, there's two more. And this one actually is foundational because it enables the third one. And so we're gonna talk about this. This is called Object-Spatial Programming. So this is it's an enhancement to object-oriented programming. So the semantics of this supersets object-oriented programming. So you still have classes and methods and all the stuff you know and love, all the stuff you know how to use, but it allows you to express the connectivity between your objects as well. Now I'm gonna have a separate video that goes deep on that, but let's look at what that looks like from a developer standpoint. So in traditional programming, all you have are classes. You just have classes with object semantics, etc., right? So you create a class. In Python, you have to essentially monkey patch in your fields, which is interesting, which is an interesting choice. But So you have to monkey patch your fields in with an init. And then, in this particular application, you're trying to represent the places a tourist has visited, right? This is a very intuitive way to communicate this abstraction. So of course you could pass a tourist object to your landmark, and your landmark can then append, oh, this tourist visited me. It can append it to the tourist object, etc. Right? So this is a traditional object-oriented, very simple thing to do. And so you're kind of passing these variables into the landmark, and you have to, you build your world by constructing a list of those places. And then, your tourist, for the place in places, your tourist can call place.react. Now because this is how we've coded for the last 50 years, it's like, okay, that doesn't seem conceptually hard. And this seems reasonable, but this abstraction, we can add more semantics on top of this capability to express this more naturally. And this actually is relevant to many problems. And let's look at what you can do with Object-Spatial. So this node is also a class. We also have edges. It's not in this example, but edges are a class. These are types of classes. So we add 3 types of classes on top of regular class. So we have node type classes, edge type classes, and we have these things called walker type classes. Okay. Now, for a problem like this, you can express it more naturally, right? So here you can have nodes of these local cafe landmark, and then you can express connections between those nodes with this kind of syntax. You have a root node, and off of your root node, you can have your local, your landmark, your cafe, and you have another landmark, right? So you have a graph, and then your tourist, which is also a class, it's just an object. It's all object-oriented programming supersetted with new semantics. Your tourist can then visit places in that graph by just traveling edges, okay? So object-oriented programming allows your methods to interact with objects in a graph structure, and it makes certain problems more intuitive to articulate. Now, I'm going to go deeper on these kind of semantics at some point in some other video and how it actually helps many problems become easier. But it's when you think about a problem like you're representing a tourist or a vehicle in object-oriented programming, and you want to take an object of that vehicle and have that object interact with other objects that can be represented in a graph, we added semantics to object-oriented programming to allow you to express that. Now, I talk about this being so that's interesting from an intellectual standpoint, but I talked about it enabling another capability in abstraction that I think is very interesting, and I think it can help us in this world. Now look, so here we have what we call 0 to infinite scale without code changes. So that means that you can write an application like this on the left. You can have it run locally. Here we just have one type of node, which is a class, and 2 types of walkers, which are also classes, are also objects, with slightly improved new semantics. And this program can turn into a distributed application that runs on 1 million machines at scale, or it can run locally in your command line. And you don't have to change the code. So you can write your programs and relinquish all of that complexity. And it comes from the notion of root, right? So root has semantics where anything attached to root will persist across invocations. Your walkers can automatically become endpoints that you can call from a client side. And then the root, there is a unique root per authenticated user. And then that root connects to objects that automatically become a database. And then the decisioning of, well, how does it scale? Where does it run? All of this stuff becomes an automated runtime problem. Today, as a developer, if you want to write an application in traditional programming that will run at scale, something expressed like this would have to turn into a lot more complexity, right? And anyone who's done this before recognize these libraries and fast API, and then you have to have your security and algorithm, and all this complexity needs to be specified by a user. And then you have to create tokens. You have to do a lot of this boilerplate, create your endpoints, and do a this boilerplate, and then you're interacting with the database. You're deciding on the schema, and you're deciding on the policies as to how database will be kind of organized for your application. But that becomes unnecessary with a simple extension to the object spatial semantics, where you have the notion of a root and persistence across runs. Now, that sounds technical. At the end of the day, what that means for a developer is you just write your programs like this, just using the objects that you know and love. You can also have connectivity between objects, which is useful. And in reality, most of your data is some kind of, schema or graph that you're interacting with anyway. And that information can be used to automate all of this stuff. So you don't have to know DevOps. You don't have to understand all this complexity. We think of that as like memory management, right? Deciding what, from a traditional computer science standpoint, like you have to decide which registers are going to be spilled to what memory locations. When we were only writing an assembly, you had to do all of that. But the abstraction of, say, functional programming, procedural programming, hit all of that, new and delete. And then we abstracted that away with dynamic memory allocation, garbage collection, right? So we're abstracting away databases at scale. We're abstracting away like user management and the creation of protocols as to how all these things can run, because if you articulate the intent of your program, you should be able to have runtimes and intelligent runtimes do that for you. And we do this. And we do this in production. And we've proved this out at scale. Now, all of these are ripe for future development, right? We've built the first version of these abstractions. But from an implementation standpoint, there's so much to do. And so that's why we have this plugin ecosystem, so we can rapidly prototype things. We can adapt a plugin that just hooks into, say, an AWS app engine type deal, or you can talk straight to Kubernetes and all these things. And that is not the work of someone writing Jack. That comes as libraries and stuff that's in plugins that's in your Python ecosystem. We actually leverage the same plugin interface as PyTest, right? To realize these plugins. So these are three of the key ideas for how do we now write AI integrated software. How do we articulate our programs to better map to the semantics of our intent, right? Like this, and that argument really becomes clear because there should not be we shouldn't have a list of locations. We should have the objects have a rich representations of their relationships to each other to extend OOP for that. And then that allows for runtimes to be able to automate things like scale, what data lives in memory, distributed memory, or on, your Postgres database network file system, all of that complexity, Kubernetes resources, all automated as now a runtime problem, kind of like garbage collection. So these are the key three innovations. And that has enabled us to write Twitter in 200 lines of code. And it runs a version of course, we rewrote a version of Twitter or X, whatever. It's not actual Twitter. But it scales, and it's written in 200 lines of code, down from around 10 to 15,000 lines of code. So we've done that. And we've also built, this is like an agentic coding agent that looks a lot like, what you would see in Claude Code, etc. That kind of use case. We were able to reduce this from all of this code, I don't know how many lines, down to just this amount of code, and it works better with higher accuracy. And so these are the value adds. Now, I promised a couple additional treats. I'll just do like two, okay? So I think first, let me just go back to this picture, just to kind of emphasize that introducing these kinds of new abstractions, hopefully you can see from what I've described so far, why it's useful to have the ability to innovate at the language level, right? You can see why that might be useful. And so that's why we made that decision. Now we made that decision to be as adoptable as possible, as minimal ask of the developer as possible. And we think the sweet spot was to extend Python. And so we have this very, very rich philosophy that we adhere to, where to the Python VM, everything should look like Python, right? And so we achieve that. And to the developer, from a language level, much like C++ to C, we aim to both make the improvements that make sense for developer productivity while making the syntax as gradually similar as possible. So what I'm going to do is I'll just show you just a little example of that. On the left we have Python. This is Python you could recognize, right? Guess game, the number game, etc. On the right, this is Jack, right? This is legal Jack syntax. And what you'll observe is it's like you can express Jack syntax that's almost exactly like Python. So here's the classic, let's call it monkey patch strat classes, the monkey patch strat classes. You can do that here, right? This one has more features, like there's no one over here. So these are, yeah, but you get the point. So here your self.attempts equals attempts. It's the same kind of thing. Your classes are not implemented. You're importing random. It's the same syntax, right? Except there's a couple of these little twiddles, like the with entry, a hygienic thing. And then we do curly braces and semicolons. We don't do the indent thing that Python does. But yeah, this is very easy to be a Python developer and then articulate whatever you wanted to in Python. You can articulate that in Jack. We also have, you can inline pure Python too in your Jack program, right? That's super easy. I don't have that in this particular example. But then, you can also do things that are a little bit better, right? So instead of class, you could use obj, right? And so this particular Jack in 5 minutes, maybe it'll take most people 10. I don't know why we put 5, but here you can kind of see, like, okay, to me, this is an improvement, of course. And most object-oriented languages let you define your fields and then auto-generate a constructor, right? And data classes do that. This is actually a data class in Python semantics, basically. And so you can see some of these improvements. And of course, we have organizational improvements. So there's improvements that you can also express in Jack, but this is legal Jack. Your legal Jack can look a lot like Python. So we wanted to make it very easy for developers to kind of adopt. So if you want to throw in just one Jack module with a by keyword, instead of using, say, the decorator mode, that's very easy to do. You can follow this kind of capability to then just add your one Jack module. You can write it pretty much in a Pythonic way if you wanted, and then to not use any of the other improvements we have, and then you can just go. Now, so I'll just say that part when it comes to how easy is it for you to engage Jack. Now, what I'll say though, too, and this is the other like bonus, and this is what we don't recommend this because we don't think it's fully realizing the advancement of increasing our abstractions, but you can do this. And what it is you can use Jack primarily as a, let's see, where is it? I'll just do it here. You can use Jack as a library, right? So this is the site that's all about the ByLLM feature, and it's linked off of the other site. And one thing we show here is, let's just look at this example. So this is an example where we show traditional programming, right? So this is the traditional programming you might be used to, Python, and then this would be the Jack way to do it. Now, you can do it in Python too, and use Jack as a library. So this ByLLM decorator is the same abstraction as this ByLLM that's in the Jack code. This actually applies to everything written in Jack. So let me show you. I'm going to show you. This was the treat at the end that I promised. I'm going to show you using a real example, right? So, and then the treat is this this keyword that I'm just not keyword, but this tool that the way Jack works, right? Tool that will show this. Okay, so let's take one of, just to emphasize that everything is Python. Let's just take one of these applications. Let's take this one. This one you might think looks most exotic because it has this visit thing and all that stuff, right? Like, well, how does that become pure Python? Well, of course it is, because it's Python bytecode, you could express this in pure Python. And so let me show you, and then this, like, this doesn't seem like it's, how do you use, so let's just cut and paste this, right? So let me just cut and paste this and I'll stick it into VS Code. Let's see if we still have that running. Okay, here we go. Let me make sure you can see what you need to see. Good. So, I already have it up. Oh, okay. Spoiler alert. I was just testing this right before. Let's just do this from scratch again. So you probably already saw. It's all good though. All right, cool. So of course, Jack extension is the first thing you should do. So, okay, this is actually the program. I don't even have to cut and paste it. Let me see. Let me just clear all this out. Okay, just so I can show you the example step by step. So you can cut and paste your application over here, right? This is Jack code, beautiful, if I may say so myself, right? That shows the more natural way to express this. Now, all you need to do, we call this first.jack. All you need to do to see a Python version. Oh, let me make this a little bigger. Okay, good. You guys can see that. All right, good. So all you need to do to see a Python version is run Jack. You know how to run it, right? But you can run Jack and then use this Jack to Py option for first.jack, right? Which is this file. So when you run this, it's just going to render. It's going to render pure Python. So I'm going to do this into a file called first2.py. So let's look at first2.py. Okay, so this is first2.py. Let's do a side-by-side here. All right. So let me make this a little smaller so you can see more of it. So if you look at this, right, of course, when you render the pure Python version of this Jack module, you essentially get to see what the decorator interface looks like, right? So instead of with entry and all that goodness, which is incredibly powerful, and you got to dig in deeper, we'll look at it more later, because your walkers can enter nodes and then trigger execution on that node. You can actually do this in library mode. You just use the base class node, and you have the entry decorator on a regular Python function. This is pure Python on the right. And then your connect, right? You can use the library mode to connect your roots to your objects and etc. Right? So something that looks even a little bit more on the exotic side, of course, the ByLLM feature is very, very obvious. It's like just by at the function, you could do a pass or an ellipses in your Python land to get the same abstraction. You can also get the same abstractions in pure Python if you wanted to do it in library mode. But if you understand this, how to use this library, what I think you'll find it more natural to implement this, right? The learning curve to learning the library is this, the same as like expressing it. But I'll leave it to you guys, how you want to do things and how you want to use it. This is our official recommendation. And I think that's all I want to talk about in this video. Like, is there anything else I missed? Probably. I'll think about it and I'll do another video later. Anyway, with that, guys, thanks so much for listening. I know this is a long one, but it kind of needed to be. And my goal was to mind dump everything. And I think I've achieved that. And feel free to engage and ask me questions and ask the whole community questions, the whole team questions, on the various Discord channels and so forth. And so with that, thank you all for listening, and I'll see you on the next one. Peace.